Throughout history, salt has been used by humans for thousands of years, either as a seasoning or a preserving food method. In ancient Greek, salt was so valuable that traders used it as a currency. Nowadays, it serves as an essential building block in the chemical industry. Salt that we are all familiar with might look something like this. But did you know that there are tons of salts out there? In this video, we will be discussing about definition of salt, soluble salt, insoluble salts, and how to make them in the lab.
Salts compose of related numbers of cations and anions. Therefore, the product is electrically neutral. There are three main reactions for the production of salt, as Group 2 mentioned before. There's neutralization, which is basically when an acid and a base react to form water in a salt, which involves in the combination of hydrogen and hydroxide ions to generate water. And the other two reactions are the acid-carbonate reaction and the acid or base metal reaction. Now that we just learned the definition of salt, let's talk about the general categories of salts, which are soluble and insoluble salts. The key difference between them is that soluble salts can dissolve in water at room temperature, whereas insoluble salts cannot. Why? Glad you asked. Soluble salts dissolve in water as water molecules tend to attract the ions in the compound, making them separate from each other, resulting in the dissolution of the salt. The dissolution of soluble salts in water produces a highly conductive aqueous solution, as the ions that dissolve in water conduct electricity. On the other hand, the ions of insoluble salts aren't attracted to the water molecules, making them undissolvable in water. In short, insoluble salts are nonpolar compounds that can't conduct electricity.
Now that we got past the studying stuff, let's get on with the boring stuff. Remember this table? This is not a question, this is an order. Any compounds that have ions grouped above can refer to this table on what compound is soluble or insoluble in water. Now here's a little trick. Do you remember this? Yeah, me neither. This helps you remember that most compounds with these ions can dissolve in water. The 4 stand for phosphates, car for carbonates, so for sulfides, and I for hydroxide. The 4 of them generally can dissolve in water. The exceptions for this is when they are matched with Na, K, Ba, or SH4. When matched with these, they can dissolve in water. For example, barium hydroxide or potassium sulfide. You can look at the table to see that they can actually dissolve in water.